Hello and welcome back to Calculus 1 Exam 3 review. Yeah, so much enthusiasm there. That means that I have to sit down and write this thing and then bring it and print it and then copy it and then bring it and sit bored over here while you're enjoying the problems and then grade it. Right? So, good. Exam 3 on Chapter 4, 10 problems. Or in that vicinity. If there are too many A's and B's, it might be 9. So Chapter 4, 10 problems, and we are focusing on its applied derivatives, right? So there are a few things that you really need to know. So we start with the min-max problems. That's 4.1. Then there's a mean value theorem. Then first derivative test, second derivative test, graphing, linearization. Now part of the same lecture were differentials, but I have to split that. L'Hopital's rule, antiderivatives, optimization, and differentials, which are word problems. Linearization as a tangent line. L'Hopital's rule has 0 over 0, infinity over infinity, 0 times infinity, infinity minus infinity, or those exponential ones. Antiderivative is basic integration plus c. You will have plus c on every problem because definite integrals are in Chapter 5. Graphing, all given, just graph. If you remember anything from 4.4, you know that I had that shopping list of 13 things you have to compute before you graph, right? X-intercept, Y-intercept, domain, range, the first derivative, second derivative, first derivative test, second derivative test, min, max, all of that stuff, right? 13 different things to get to graphing. All of those values and asymptotes, right? All of that will be given to you, and you are supposed to just draw the graph looking at the stuff. Separate problems for first and second derivative test. So these are different functions on different pages. They have nothing to do with each other. First derivative test, you need intervals. I can't even spell. Intervals of increase, decrease. That's your answer. And over here, intervals of concave up, concave down. Mean value theorem. Find C plus theory, right? To be able to state what the formula is. And then min-max, that's just easy. Right? Min-max, you take the derivative, you set equal to 0, find the critical point, and there you go. Critical point is your min or max. That's the exam. 10 problems. L'Hopital rule will have parts. It should. Integration should have parts, right? Now the rest of the problem, they all have parts by themselves. Linearization. You have that formula for linearization, L of x equals to f of a plus f prime of a x minus a. That's just a one-line tangent line equation, formula. If you don't feel like learning that, even though you're going to need that in Calc 2, I did say that, because you'll expand on it, you can just use the regular tangent line, right? Instead of the formula for linearization, you can just use the regular tangent line procedure. L'Hopital's rule, at least one of those problems will be repeated L'Hopital, that you have to do it 2 or 3 times. Anti-derivatives, I already said at least A and B, maybe A, B, C. Make sure you have plus C on all of them, because they're all indefinite. I don't think I have anything else to say. Do you have any questions? You do? Yes, let's talk.
Can you show an example of the linearization?
Yes, which one?
Whichever one you want to do.
Now you're going to say the one that is going to be on a test.
Yes. I don't want to say that, but you know.
But I read minds. Isn't that scary? You thought of it and I knew it. What? Stop thinking about that. That's the freakiest one. I can say something. Yes.
Yeah. Okay. So historically, I struggled with word problems. Do you have any link to a place where I can receive word problem after word problem?
Well, there are word problem sections, and all of the problems in that section are word problems. So 4.4,
Okay.
and then half of the differentials, right? Linearization. There we go.
What section was that? 4.1?
Linearization is in 4.6.
Alright.
4.6. This is a nice problem. 31. I like it. Should have saved this one. F of x is given as 1 over cube root of x plus 8. And they want to calculate f of negative 0.1. No. Yes. Good. Nice. Okay, let's take a look at this together. So we can do this either as a tangent line problem or as linearization with the formula, which is give you the same line at the end.
Do you mind doing both?
I don't mind. Do you want them side by side or one above the other? See? Side by side? See? There we go. All right, so this is the tangent line approach. So we will set a to equal to 0 because the 0 is the closest nice number to compute things at for negative 0.1, right? Now we have to take the first derivative of the formula. Now I'm going to write this formula as x plus 8 raised to the negative 1/3, so it's easier to take derivative. Negative 1/3 x plus 8 to the negative 4/3. So that's my derivative. And to simplify it, we'll put negative 1 over 3. And then we'll put the cube root of x plus 8, everything raised to the 4th power, because it's by negative, that's why it's in the denominator. So now m is equal to f prime of a, and a is 0. So m is equal to negative 1 over 3 times cube root of 8 to the 4th power. That's negative 1 over 3 times 2 to the 4th. 2 to the 4th is 16. So we have negative 1 over 3 times 16, and that's negative 1 over 48. Now that I have this, I have a slope. And I can calculate, if I plug in 0, I get 1/2. Okay? So we have 0, 1/2, and m equals negative 1 over 48. Plug into y equal mx plus b to get 1/2 is equal to negative 1 over 48 times 0 plus b, from where b is clearly 1/2. So y equals m is negative 1 over 48 x plus 1/2. So if all calculations went well, I should be able to do this now with linearization formula and get the same result. So this is linearization. We have L of x is equal to f of a plus f prime of a times x minus a. So you are responsible for this formula. You need to know it. So all we need to do is to plug stuff in. We know a is 0. So plug a in original function. Well, let's write it. L of x is going to be f of 0 plus the derivative computed at 0 times x minus 0, because each a is 0. So L of x is equal to function computed at 0. That's 1/2. Plus derivative computed at 0. And we did that. That was -1/48. And then just times x. So we have L of x equal -1/48x plus 1/2. Nice, got it. Same. Now if you're comparing these two side by side, please note that the bulk of the work that was done for the tangent line was actually taking the derivatives, which I only stole from the other, right? So you have to add all the space for figuring out the derivative to the right-hand side. These methods are not going to be that far apart, you know? They calculate the same thing in the end. So whatever you pick, right? Linearization is cool to know, because when you get to chapter 9 in Calc 2, you will add infinitely many terms to it. So right now you only have 2 terms, first and the second, in a series. What else?
One of the one problems, please.
Which one?
The one problem.
Can you do 30?
I hope I can. Is that 4.4 or which section you're in?
4.5, shortest ladder.
4.5, shortest ladder, you said problem 30. Ooh. Shortest ladder. Good. Look at that. A 10 feet tall fence runs parallel to the wall of a house at a distance of 4 feet. Find the length of the shortest ladder that extends from the ground to the house without touching the fence, assuming the vertical... Well, that's like the barely touching the fence. Because... So this is section 4.6, problem number 30. And we have a situation where we have this house. Look at that. And then we have fence, which is 4 feet away. That's a side fence. And then we want to put the ladder and that's 10 feet. So oh no, the fence is 10. We don't know what the size of the ladder is. Fence is 10. Nice.
That's 4 feet from the house, right?
Yes. So what do I have? Well, I can take this triangle and put it on the side. With 10 and 4, and I guess age for the height of the ladder, or let's use just x. X length of the ladder. I need to label this because I have to set up the problem. I have to start writing some equations. So what should we do? Well, we're going to label this one as a height and this one as, I guess you can do B for base or just A, whatever. A squared plus B squared, no, by H squared is equal to X squared. What happened?
Rewrite H turns out that. So like.
I can't hear you from the air conditioning.
We're going to figure out the angle at which X sits, right? Or the length of it.
Well, they want the X to be minimum length. So we need to minimize X. Which means that I have to remove both A and H to get them in terms of X, and then we can differentiate, right? So we write our proportion, right? If the whole thing is A, then this is A minus 4. So we have A is to H what A minus 4 is to 10. So flip both sides. H over A is 10 over A minus 4. Multiply A to the other side. H equals 10A over A minus 4. So now the new equation over here is A squared plus 10A over A minus 4 equals to X squared, and then this is a plus. So X is the plus minus square root of, oh, do I really need this? Huh. So let me just erase this thing when I watch. So here we go. This one over here is mathematical model. So X is equal to plus minus square root of A squared plus 10A over A minus 4. So now the derivative, and you set it equal to 0. I don't like this because a is constant, a is not a variable. This problem is tricky. I like it.
This is the big one.
I think A is a variable here.
Yes, x is a constant.
Okay.
So let's find the derivative. So x prime would be what? Plus minus 1 over 2 square root of a squared plus 10 a over a minus, no, not everything, 10a over a minus 4 times the derivative of the inside, okay, so the derivative of the inside is 2a plus, and now we have to do quotient rule. It's not gonna fit here. Plus, there we go. The derivative of this is take the square root as is times the derivative of the inside, so all I need to do is to find the derivative. So that's a minus 4 squared, a minus 4 times 10 minus 10a times 1. Good. This is really long. Plus minus 1 over 2 square root of a squared plus 10a times 2a plus, and now we have two a. Is there a way to simplify this? No, really. You can kick 10 out, but it didn't change much. So this will be a minus 4 okay, so a minus, if I factor out 10, a minus 4 minus a divided by a minus 4 squared. I just need to get the this one. There's over a minus 4 here. So plus 10a over...
That's a plus 10a over a minus 4.
Yeah, I'm just gonna see a plus minus 4, but I can't... Like, I don't like it. And this one stays as is. Well, these a's will cancel. So 2a minus 40 over a minus 4 squared. There we go. So all we need to do is to set this equal to 0. You will find wonderful examples. I like it. Let me go one more step over here, because when you distribute this, 2a and it cancels, so plus minus a cancels, so a over square root of a squared plus 10a over a minus 4. And when you distribute to the second one, you have minus 20 over 2 times this times that. A minus 4 squared. And I've said, well, why do I have extra 2 there? Because 20 with this 2 cancels the 40. The denominator is wrong. So 2 from here cancels the 40, gets a 20 times 1, and now you have square root of a squared plus 10a over what? A minus 4 squared. This might be good. Times this, times this, times this. Oh no, that's in denominator already, so it's times. Okay. Come on, pen. There we go. Times a minus 4 squared. Alright, that's better. There is a minus 4 basic. Not squared. Alright, good. Whew. So now I need to multiply a minus 4 squared on the other one to simplify. To combine them into a single. And I have a minus 4 squared minus 20 divided by this parenthesis times the square root. We don't care about that because when you set equal to 0, you only worry about the numerator. And the numerator is going to be a times, and now you square this out, that's going to be a squared minus 8a plus 16, and then we have minus 20 equal to 0. So we're getting a cubed minus 8a squared plus 16a minus 20 equals to 0. That's the equation we need to solve. And since this is a polynomial of the third order, can we easily factor this? No. No. How about 8 and 20? No. So, let's see what Wolfram Alpha says. Solve, and we have x cubed minus 8x squared plus 16 I said plus 16x minus 20 equal to 0. We have one real and two complex solutions. So the solution that it's real is a equals to 5.85. And that's how far you have to be. That's A. In feet. So make sure next time the ladder is needed.
I just won't be putting a ladder up against the house.
You'll hire someone to do it.
Exactly. Let them figure it out.
It's like, hey, what are you doing? I'm installing the kitchen. No, you don't. You hire someone to install the kitchen. You know, the kitchen. First derivative test we did actually today. That was good. At the beginning of the class, we did first derivative test, we did second derivative test, we did linearization. This is the word problem for optimization. We did the L'Hopital's rule, the one with infinity minus infinity, and then it worked out to be 0 over 0. The things we haven't touched upon yet, well, this was min and max at the same time. You take the first derivative, say equal to 0, that's first lecture, 4.1. And so the only things we didn't talk about were, well, we did a lot of integrals today too, right?
A lot of what?
Integrals,
Yes.
which is 4.9. Just remember that 4.9 has plus c on every single one. We didn't talk about differentials. We did one of the mean value theorem, right? That was also the question. I remember looking for c. Oh no, that was for integrals. Mean value theorem is for integrals. So the only two things that we didn't look at: mean value theorem and mean value theorem graphing, and one more thing, whatever it was. Do you have any questions for that? I'm not in a rush. Oh, students usually ask, how do I know the difference between the word problems? Well, optimization word problem is looking for a minimum or maximum somewhere, and differentials are looking to approximate the change. So they're completely different wording for different situations. So if you see approximate the change for the function blah blah blah, that's differentials. If you see that you want to work with two equations, have objective and constraint, something is getting minimized or maximized, you know, want maximum profit, maximum revenue, minimum cost, minimum surface area for the least amount of material, maximum volume to put the stuff inside. So as soon as you see those words minimum and maximum floating about, that's your optimization word problem. If you have the words approximate the change, well, that's what differentials do. dy is approximating delta y. Delta y is the exact change. dy is the approximate. But you have all of this obviously worked out in details in the online lectures. That's it? Yeah? First time, second time, third time. So, bye.